everyone, welcome back to the channel. This is our 5th class on circles, and in this captivating video we dive into the essential process of revising the previous lecture before embarking on our next chapter of learning, where we will be uncovering the concepts of radical axis, radical center and coaxial circles, perfect for the students preparing for IIT Main and IIT Advanced. Our engaging explanations and visual aids will make complex idea easy to grasp. Join us as we unravel the magic of geometry and boost your exam confidence with expert tips and methodical approaches. Don't miss out. Hit the subscribe button and tap the notification bell for more in-depth tutorials that turn intimidation into inspiration.
So this is the synopsis of my previous class. In that class, I have discussed about the family of circles, where I have considered 5 cases. So let me just go through a very quick revision before starting the new topic today. So passing through the point of intersection of a circle and a line. Family of circles passing through the point of intersection of a given circle and a line is given by, if this is the circle and we are having a line, then any circle which is passing through the point of intersection of these 2 points is given by S1 plus lambda L equals to 0, where the equation of the circle is S1 equals to 0 and the equation of the line is L equals to 0, right? The next case was family of circles passing through the point of intersection of 2 given circles. The 2 circles are S1 equals to 0 and S2 equals to 0. So any circle which is passing through the point of intersection of these 2 circles is given by what? Any circle which is passing through the point of intersection of these 2 given circles is given by S1 plus lambda S2 equals to 0. But in this case, we must be careful about one thing, that your lambda cannot be equals to minus 1. Why? Because if you take lambda equals to minus 1, this equation no more remains the equation of a circle. That's the reason we should be careful while using this formula, that your lambda cannot be equals to minus 1. Next, we have learned for concentric circles, we know that if the equation of any circle is, let us say, x square plus y square plus 2g1x plus 2f1y plus c1 equals to 0, then the equation of any concentric circle to this circle is given by x square plus y square. Everything remains same. Only the constant term will differ, because concentric circle means we are having the same center. Only the radius differs, and that's the reason why I have added a parameter lambda instead of the constant c1 given in the original equation of the circle. In case 4, we have learned that when a family of circles are passing through 2 given points, when it is passing through 2 given points, I will construct a circle taking these 2 points as the extremities of the diameter of that circle. So the equation of that circle will be this one equals to 0, right? That will be the equation of a circle whose extremities of the diameter are x1, y1 and then we will find out the equation of the line joining these 2 points, which in the determinant form we know it can be written in this way. I have already discussed that in previous lecture. Therefore, the family of circles which are passing through the point of intersection of this circle and this line is given by this expression plus lambda times the expression for the straight line equals to 0. Okay, so this is the family of circles. Okay, and the last thing that we have done, that when you have to find out the family of circles which is tangent to this line L equals to 0 at the point x1, y1. So the family of all the circles where L equals to 0 is the tangent to all those circles at the point x1, y1 is given by this one. How we have done? Because we have again constructed a circle at this point, which will be a point circle, which is written as x minus x1 whole square plus y minus y1 whole square plus lambda L equals to 0. Okay. The equation of the circle is this equals to 0 and L is the line. So any circle which is passing to the point of intersection of this point circle and this line is given by this equation, right? So this was our case 6. That was the last case of all family of circles. Now what we have learned in the previous lecture is the angle between two circles. If suppose two circles are given to us, then if we want to find out the angle between these two circles, as I told you, the angle between two curves is always the angle between the tangents at their common point of intersection. And only in case of circle, because we are having 2 points of intersection, as I told you that circles are symmetric. So to find out the angle between the circles, either you can find it here or you can find it here. Both will be of same angle, right? If this angle is theta, then this angle is also theta. So no need to find out at 2 points. At only 1 point, if you find out the angle, that will serve our purpose. Now, what we have learned, that if the radius of the first circle be R1, the radius of the second circle be R2, and the distance between the centers of these two circles be D, then the angle theta is written as cos theta equals to modulus of R1 square plus R2 square minus D square divided by 2 times R1 into R2. And we have learned at the same time the condition for orthogonality. What do you mean by orthogonality? I mean the two circles are orthogonal. What do you mean by that? When the angle between these two circles is 90 degree, then we say that these two circles intersect each other orthogonally. And the condition was, naturally, if this theta is 90 degree, so what will happen? So cos 90 becomes 0. So naturally R1 square plus R2 square minus D square will become 0. So from there we can write R1 square plus R2 square equals to D square. Okay. Now when the equation of two circles are given to you, simply by expanding this formula, we will get the relation between the two circles when the two circles intersect each other orthogonally is this one. 2 times G1 G2 plus 2 times F1 F2 equals to C1 plus C2. So both the formulae we have to remember. So these are the things that we have covered in our previous class. Okay, so now we will move for the new topic that we are going to start today is the radical axis. So what is a radical axis? Radical axis is basically the locus of a point moving in a plane in such a way that its power with respect to two circles are always same. Let us say h, k be any point on the locus. Let h, k be any point on the locus. Now from this point, what we have done, let us say there are two circles. This is the first one and this is the second one. And now we are drawing two tangents from the point h, k on the first circle and on the second circle. The equation of the first circle is S1 equals to 0 and the equation of the second circle is S2 equals to 0. So to find out the radical axis, we have to find out the locus of the point, let us say P. According to the definition, the power with respect to two circles, they are same. So what is the power of the point P with respect to the first circle? It is our S1. And what is the power of the point P with respect to the second circle? It is S2. By the definition, S1 equals to S2. That implies, for the first circle, I am writing the power of the point P, which is equals to the power of the point P with respect to the second circle. Is it clear? So now this thing goes off. So we are actually having 2 times G1 minus G2H plus 2 times F1 minus F2K plus C1 minus C2 equals to 0. Therefore, the equation of the locus is, which is basically our radical axis, its equation will be this. Am I correct? Now, if you observe this equation, which is basically the equation of the radical axis, we are actually getting this equation simply by subtracting one equation from the other. So whenever two circles are given to us and they have arcs to find out the radical axis, we will simply subtract one equation from the other to get the equation of the radical axis. Is it clear? Now, radical axis is basically independent of the position of two circles. The example that we have taken here, both the circles are disjoint. So here we have seen that there is a radical axis. Now when these two circles touch each other externally, then also we are having a radical axis. If these two circles intersect at 2 points, then also it is possible to get a radical axis. Even when one circle is touching the other circle internally, then also you are going to have the radical axis. The only 2 cases where we are not going to have any radical axis, it means that in those 2 cases, the radical axis is not at all defined. When you find that one circle is very much inside the other circle, in this scenario, there will be no radical axis, right? So in this case, when one circle is inside the other circle, we are not going to get any radical axis. And the second case is that when these two circles are concentric, that is, they are having the same center. If they are having the same center, in that case also we are not going to have any radical axis. Other than these 2 cases, everywhere, irrespective of the position of 2 circles, radical axis is possible. Is it clear?
So what we have learned about the radical axis? It is the locus of a point moving in a plane in such a way that its power with respect to 2 circles are always equal. And how we get the equation of the radical axis? We have been given 2 equations of the circle. You subtract one equation from the other to get the equation of the radical axis, right? Moreover, if the 2 circles are disjoint, or whether they are intersecting or they are touching internally or externally, everywhere you are going to get the radical axis. Okay, the only restriction is that where your radical axis is not defined, where it is when one circle lies inside the other circle. In that case, your radical axis is not defined. Moreover, if the circles are concentric, in that case also you are not going to get any radical axis. Other than that, irrespective of the position of two circles, you are always going to get the radical axis. Okay, let's move to the computer screen.
Now let us come for the properties of radical axis. The length of tangents drawn from the radical axis on the circles are always equal. It's quite obvious. Why? Suppose, let me take two circles. And we know that the definition of the radical axis is what? It is the locus of the point. It is the locus of the point in which the power of the point with respect to two circles are equal. If the first circle is S1 equals to 0 and the second circle is S2 equals to 0, so we know that any point you take on this locus, that is on the radical axis, and if you draw tangents, so power of the point, let us say P, will be same. That is the definition of the radical axis. Your S1 is same as your S2. Therefore, square root of S1 will be equals to square root of S2. And what is square root of S1? This is the length of the tangent from the point P on the first circle. This is the length of the tangent drawn from point P on the second circle. So what we have learned, that from any point on the radical axis, if you draw tangents to the two circles, then their length of tangents will be always equal. Clear? So this is our property 1 for radical axis. The second property states that the line joining the center of the circles is always perpendicular to the radical axis. What they are saying is, if you join the two centers, of the given circle, then the line joining these two centers will be always perpendicular on the radical axis. Is it clear? So this is our property 2. Let me just prove this one. Let us say S1 is, the equation of the first circle is, and the equation of the second circle is, now what is the center of the first circle? The center of the first circle is, center of S1 is minus G1 minus F1, and the center of S2 is minus G2 minus F2. Am I correct? And the equation of the radical axis is 2 times G1 minus G2x 2 times F1 minus F2y plus C1 minus C2 equals to 0. Now, what is the slope? What is the slope of the line joining these two centers C1, C2? So, the slope of C1, C2 is F2 minus F1 divided by G2 minus G1. Okay? And what is the slope of the radical axis? From this equation we are getting the slope of the radical axis is minus G1 G2 divided by F1 minus F2. Am I correct? So this is the slope of the line joining the two centers, and this is the slope of the radical axis. Now, if I multiply these two slopes, we are getting This can be written as minus same thing G2 minus G1 by F2 minus F1. So we can easily see that this will go off. So we are left with minus 1. It means that C1, C2, that is the line joining the two centers, is perpendicular on the radical axis. That we have proved. Is it clear to all? So that was our second property for radical axis. The line joining the two centers of the circle is always perpendicular on the radical axis. Okay? Now, the third property says that when two circles touch each other externally. Okay, so let me just draw two circles first, which touch each other externally. These are the two circles which are touching each other externally. Now, what the property says? The property says that when two circles touch each other externally, then the transverse common tangent and the radical axis is the same line. That is, if I draw the transverse common tangent here, this is the transverse common tangent, right? Now, they are saying that the property says that this transverse common tangent and the radical axis, they are same. That's the property. Is it clear? So, let me just prove this one, that this transverse common tangent is basically the radical axis. Now, how to prove this one? I hope it will be sufficient to prove that from any point on this transverse common tangent, if we draw two tangents to these two circles, if I draw two tangents to these two circles from this point on the transverse common tangent, and if we can prove that this length and this length, they are same, then it is same of proving that this line, that is the transverse common tangent, is the radical axis for these two circles. Am I correct or not? If you can prove that from any point on the transverse common tangent, the tangents drawn to two given circles, the length are equal, the length of the tangents are equal, then we can easily say that the points which are taken on the transverse common tangent is basically the points on the radical axis. In other words, we will say that the transverse common tangent and the radical axis, they are the same straight line, right? Now, I am going to prove this one. Let us say the arbitrary point that I have chosen on the transverse common tangent be P. And let the tangent drawn on the first circle, the point of contact be A, and that of point of contact of the second circle be B. And the point where the transverse common tangent is touching both the circles, let us say that point be S. So now if we consider the first circle, we can easily see that PA is equals to PS. Why? Because we all know that from any point outside a circle, when you draw two tangents, their lengths are equal. PA and PS are the two tangents of the first circle. So their length will be equal. Similarly, if we consider the point P and we consider the second circle, we can easily see that your PB is equals to PS. Why? Because PB and PS both are the length of the tangents drawn from point B on the second circle. And as they are equal, I have written that thing here. Now, both these equations are equals to PS. Therefore, I can say your PA is equals to PB. That is, any point chosen on the transverse common tangent, the length of the tangent drawn to two given circles are equal, implies that the transverse common tangent is same as your radical axis. Is it clear to everyone? Okay, so let us move for the next property. The next property states that when two circles touch each other internally, their density and the radical axis is again the same axis. So what they're saying that two circles touch each other internally. So let me draw the circles first. Let me say this is my one circle and this is the other circle. They are touching each other internally. So the direct common tangent will be this line. Yes or no? Okay. Now we have to prove according to our property, it is saying that this direct common tangent and the radical axis for these two circles, S1 equals to 0 and S2 equals to 0, they are the same line. So we have to now prove that any point, if we want to prove that this direct common tangent and the radical axis, they are the same line, what we will do, we will choose any point on this direct common tangent and we will show that from this point, if we draw tangents to the given two circles, their lengths are equal. If you can prove that, then we will say, that the point which is chosen on the direct common tangent is nothing but a point on the radical axis according to the definition. Is it clear? So let me just draw two tangents first and let us try to prove that the length of these two tangents, they are same. This is the first tangent I have drawn in S1 and this is the second tangent I have drawn in S2. Let me denote this thing by A and this thing by B, and let us say this point where the direct common tangent is touching both the circles be C. And any point, arbitrary point which you have chosen on the direct common tangent be P. Now our main task is to prove here that PA equals to PB. That's it. Now consider the circle S1 equals to 0. P is a point outside this circle and from this point we have drawn two tangents which are PA and PC and they must be equal. Both of them must be equal. Why? Because we know from any point outside a circle, if we draw two tangents to a circle, their lengths are always equal. These are all basic principles. Now, similarly, for the circle S2 equals to 0, look it carefully, your PC and PB, they are also equal because these two are the length of the tangents drawn from the external point P on the circle S2 equals to 0. Right? Now, comparing, if you see these two equations, we will find both these equations are equal to PC. Therefore, we can say your PA equals to PB. That is the length of the tangent PA. That is the length of the tangent to the first circle and the length of the tangent to the second circle, which is PB. They are equal. So I will say P is a point on the radical axis. At the same time, we have assumed that P was a point on the direct common tangent. So what it means? It means that your direct common tangent and the radical axis, they are the same line. Is this property clear to all? So what we have learned, whenever two circles intersect each other, or rather I should say, when two circles touch each other internally, then their direct common tangent and the radical axis are the same line, right? Let us move for the next property, which states that when two circles intersect each other, the radical axis and its common chord are the same line. Is it clear? So what they are actually saying is that it's a very common thing. We can understand this one. If two circles intersect each other, then let us say they intersect each other at the point A and B. Now, if I draw the common tangent, the common chord, this is the common chord, and this common chord is exactly the same as your radical axis. So, whenever two circles intersect each other, the radical axis and the common chord for the given two circles, they are always the same line. Clear? Now, as I have already discussed, this is our property 6, for any concentric circles, radical axis is not defined. This I have already explained. Now, the last but not the least, the property is radical axis always bisect the direct common tangent and transverse common tangent. See, this is a very common property. Very common property and easy to understand. Let me take two circles. You can take anywhere. I am taking these two are, let us say, disjoint circles. Again, I am telling you, don't be confused with the position of the circle. It can be anywhere. I am taking these two circles are disjoint. Now, if I draw two tangents, if I draw the two direct common tangents, this is one direct common tangent and another one is this one. Okay, and this is our radical axis. This is our radical axis. Now what we know that from the radical axis, we have to prove that this radical axis actually bisect these direct common tangents. Is it clear? This radical axis bisect this direct common tangent, that is this length and this length, they are same. Now, it's pretty simple to prove. We know that any point you choose on the radical axis, the length of the tangents drawn from that point to the two given circles, they are same. So, this is my one tangent, PA, and PB is my other tangent. Therefore, your PA must be equals to PB, that's for sure. Because this is the radical axis. It means what? The radical axis bisect your direct common tangent. Is it clear? Same thing here also. This is C and D. Again, QC and QD, these are the two tangents drawn on two circles. So their length will be same. Why? Because Q is a point on the radical axis according to the definition. Therefore, QC equals to QD implies that Q is a point which bisects DC. That is, the radical axis always bisect the direct common tangent. Let us try for the transverse common tangent. If I draw the transverse, I am drawing only one transverse common tangent. Let us say this is the transverse common tangent, right? Again, the proof part is pretty simple. The same thing. What is that? This is a point, let us say R. This is a point from which we have drawn two tangents. One is say RE and another one is say RF. Since R is any point on the radical axis, therefore the length of the tangent RE and RF, they will be equal. They will be equal. So what does it mean? It means that the radical axis is bisecting the transverse common tangent. Is it clear? Is this very much clear to all of you? So the last property what they have said is that radical axis always bisects the direct common tangent and transverse common tangent. So now it is clear to us, right?
So let me just summarize the properties of the radical axis we have learned. Property 1 says that the length of the tangent drawn from any point on the radical axis are equal. Why it is so? I've already explained that the locus, what is the radical axis? It is the locus of the power of the point with respect to two circles. They are equal. So we know that the length of the tangent is the square root of the power of the point. As the power of the point are equal, so obviously the length of the tangents will be equal. That is why, what is property 1? Again I am repeating, any point on the radical axis, if you draw tangents to the given circle, two circles, they will be of equal length. This is property 1. What is your property 2? The line joining the center of the given two circles is always perpendicular to the radical axis. What is the third property? When two circles touch each other externally, then the transverse common tangent and the radical axis, they are same. What is the fourth property? When two circles touch each other internally, then their direct common tangent is same as your radical axis. What is the next property? The next property is that when two circles intersect each other, then their radical axis and the common chord, they are same, right? Next property is there is no radical axis defined for concentric circles. And last but not the least, that property says that your radical axis always bisect the transverse common tangent and direct common tangent. Is it clear to all? Okay, let's move for the next part.
So let us now try some problems based on radical axis. The first question is, find out the length of the common chord of the given two circles. So let me just draw first the two circles which are given. This is one circle and this is another circle. And now we have to find out, this is the chord, which is the common chord, okay? This is also the radical axis. Both are same in this case. So they're intersecting at the point A and B. So we have to find out the length of AB, that is the length of the common chord. Now the center for the first circle is, and its radius is, and the center for the second circle is, and its radius is. So that gives us root 17 over 2. Clear? Now, what is the equation? What is the equation of AB? Which is actually the radical axis, and in this case, it is the common chord for these two given circles. Take any equation and subtract it from the other one to get the equation of the radical axis. So from here we are getting 2x plus 1 equals to 0. So 2x plus 1 equals to 0 is basically the equation of the radical axis, correct? Now remember one thing, to find out the length of AB, you can do it in two ways. Method one is, all you can do is you can simply solve this radical axis with any of these two circles. So there you are going to have the values of the extremities of AB. The moment you have the extremities of AB, you can simply apply the distance formula to get the value of AB. Am I correct or not? If you solve this equation with any of these given two circles, you are going to have the point of intersection. So the moment you have the point of intersection, it means that you know A and B. And if you know A and B, you can easily find out by using the distance formula what is the distance. This is one way of doing the sum. Other way is, you can simply join their centers. You can simply join their centers and then you join this center with the point A as well as the other center also from point A, right? Now observe carefully, the radius for this circle is 3 over 2 and the center is minus 1 comma minus 3 by 2. Let me just give a name of this. Let us say this is my C and this is my D. Now what is CD? CD is basically the perpendicular distance from C on the line AB. So what will be the perpendicular distance? What will be the perpendicular distance? It will be modulus of 2 into minus 1 plus 1 divided by root over of 2 square. So that gives us, so it is coming to half. Okay. So what is the length of CD? This is half. How I got? Simply find out the perpendicular distance from C on the line AB. That's it. And we are having CA is 3 over 2 because it is the radius of that circle. Now in the triangle ACD, look it carefully. The radical axis, we all know that the line joining the two centers of a circle with the radical axis, they are always going to be perpendicular to each other. Therefore, triangle ACD is a right angle triangle. From here we can write AC square equals to CD square plus AD square. Correct? What is AC square? 9 over 4. What is CD square? It's 1 over 4. So what is AD square? Gives us 8 over 4, that is 2. So from here we can write your AD is nothing but root 2. So what is the length of AD? It is nothing but root 2. Now as AB is the chord of the given circle and C is the center and CD is perpendicular to AB, so it is definitely going to bisect the chord. That is, D is basically the midpoint. D is the midpoint of AB. Am I right or not? C is the center of the circle and CD is perpendicular to AB, means it is going to bisect the chord, right? Therefore, AB is nothing but 2 times AD, which gives us 2 times root 2. Therefore, the length of the common chord is 2 root 2. Is it clear to all of you? Absolutely? Okay. Let me reveal the answer. Yeah. Okay. So let's move for the next problem. The question is, if the circle, one circle is given, and it states that this circle, this is one circle. What is the equation of this circle? This is the equation of this circle. Now it is saying that there is another circle which is your x square plus y square. X square plus y square is equals to 4. This is the equation of this circle. Now what happened? This circle bisects the circumference of the given first circle. It is bisecting the circumference of the first circle. Is it clear or not? Means this portion and this portion, they are same. Okay? So x square plus y square plus 4, this is bisecting the given circle. Now can you tell me when this thing is possible? When this is possible? It is possible only when their common chord, when the common chord of these two circles, which eventually is the radical axis for these two circles, is the diameter for the first circle. Is it clear? What I am saying is this circle will bisect this circle. This circle will bisect this circle. Bisect means bisects its circumference. It's only possible when the common chord for both these circles is the diameter for the first circle, whose circumference has been bisected. Okay, the diameter of that circle will be the common chord or the radical axis, in whichever way you want, you can say, will be that line, right? Now the question is, what is the center for this circle? The center for this circle is 1, minus 3. And what is the equation of this common chord or radical axis? That is, let me just give a name. Let us say this is my AB. So this is actually equation of AB. Equation of AB. What I am doing, I am simply subtracting one equation from the other. So that is the equation of the common chord in this case, which is actually our radical axis. So we are having right? So this is the equation of the common chord. Now, as the center of the first circle, 1, minus 3 lies on this common chord. Why? Because this is actually the equation of the diameter. This is actually the equation of the diameter. So the center of this circle must satisfy this equation. Yes or no? So now if I put it, what we are going to have? So A is coming to 20 minus 4, that is 16. Therefore, the required value of A is 16 here. So the main conception that we have learned from here is that when a second circle bisects the circumference of the first circle, then the common chord is always its diameter. Whose diameter? Diameter of the first circle. Always remember this. You know, these objective questions it already came in JEE. It can come in future days also. Okay, so please remember this trick to solve this kind of problem. Okay, let us just reveal the answer. Yes, it is 16. Now let's move for the next problem. The question is, two circles intersect at A and B. Let me draw the diagram. If you draw the diagram, your 80% work is over. So these are my two circles which intersect at A and B. Okay. Coordinate of A is 2, 3. I don't know the coordinate of B. The slope of the radical axis is 3 by 2. Which one is the radical axis? Your radical axis is the common chord. And the slope of AB is 3 over 2. Now, BP and BQ are the diameters of the two circles. That is, BP and BQ are the diameters of the two circles. This is, let us say, BQ and this is, say, BP. Okay? So these are the diameters of the two circles. Now you have to find out what is the equation of PQ. So let me join AP and let me join AQ. Okay. Why I have said I have joined AP and AQ? Because I don't know whether your PQ line will be a straight line or not. It's not necessary that PQ has to be a straight line, right? That is why I have said that I have joined PA and I have joined AQ. Now, to find out the equation of PQ, first what I will try to do, I will first prove that PQ is basically a straight line. Are you getting my point? Try to think about class 10 geometry. In that case, we cannot say that I have P is a different point on one circle, Q is the other point on the other circle, and A is the common point. If I join PQ, nobody guarantees that it is going to pass through A. That is, PQ will be a line. We don't know that. So first we will prove that PQ is a straight line. And then we will find out the equation of PQ. Am I clear or not? Now the question comes how to prove that. Now it is very simple thing. We can see that for the first circle, PB is the diameter. For the first circle, PB is the diameter. So what you can say? What you can say? Angle PAB is nothing but 90 degree. Why? Because we all know that angle in a semicircle is always a right angle. Therefore, PAB will be 90 degree. Clear? In the similar way, BQ is the diameter of the second circle. So, your BAQ is again going to be 90 degree. Why? Again, with the same logic, angle in a semicircle is a right angle. Therefore, we have proved that PAB is 90 and BAQ, it is also 90. Therefore, angle PAQ is 180 degree. It implies what we got? We got PAQ, the angle PAQ, which is the sum of PAB plus angle BAQ, right? Now we have proved that this is 90, this is 90, this gives us 180. That is, PAQ is a straight line. Have you understood the logic? It is a straight line. Now the moment you have that PAQ is a straight line, so now it is possible for us to find out its equation. Yes or no? Okay, now the slope of AB, they have given it is 3 by 2. Slope of AB is given by 3 by 2. Therefore, the slope of PQ will be minus 2 over 3. Why? Because AB and PQ are perpendicular to each other. Is it clear? Therefore, the slope of PQ we got minus 2 over 3. So slope you know through the point which the line PQ is passing. Therefore, its equation will be y minus 3 is minus 2 over 3 x minus 2. So that gives us, therefore the equation of PQ becomes 2x plus 3y equals to 13. Is it clear to all of you? Have you understood this? Okay, let me reveal the answer. Yes. Let's move for the next problem. The question is, two circles pass through A comma B. Here A comma B both are greater than 0. It implies that the point is in the first quadrant. And both the circles touch the coordinate axis. And you have to find out the equation of the radical axis for this circle. Is this question clear to all? There are two circles passing through A comma B. Let me just draw the circles first. So this is my one circle which is touching both the axes, and they have said that it is passing through a point. Let us say the point B, A comma B, which is somewhere in the first quadrant. There is another circle also which is also touching both these axes. Okay, it's something like this. And let us say both the circles are passing through this point, which is your A comma B. Let me denote this point by P. Okay, so now we have to find out the equation of its radical axis. So how to do this sum? That is, we have to find out the equation of this radical axis. In this case, it will be the common chord, this line, right? So this is basically the common chord. At the same time, it is the radical axis for these two given circles. Now, you have to find out the equation of this axis. How to do this? How to do this sum? Now, one thing, whenever this question comes that a circle is touching both the axes, the very first thing that it comes in my mind is that to take the center of the circle as R comma R. Since there are two circles, so let me take the first circle center be R comma R, and the second center, this is for the first circle, and for the second circle the center is, let us say, R2 comma R2, right? Therefore the radius of the first circle is R1 and radius of the second circle is R2. Okay, so how to do this sum? Now can you observe one thing, that the center for this circle is R2 comma R2, and the center, let us say this is the center, this is center for the first circle, its center is R1 comma R1. Now if I join, listen it carefully how I am applying the properties for radical axis. If I join these two centers, if I join the centers of the two given circles, as we all know that the line joining the two centers is always perpendicular to the radical axis. This property we have learned. We have learned this property. Let me just come to that point. See, the line joining, what is property 2? The line joining the center of circles is always perpendicular to the radical axis. Therefore, in our question, let me give a name of these centers. Let us say this is A and this is B. So your AB is perpendicular on the radical axis. We are sure about it, right? Now, what is the slope of AB? Slope of AB is R2 minus R1 by R2 minus R1. So that gives us slope is 1. If the slope is 1, then what will be the slope of the radical axis? The slope of the radical, as they are perpendicular to each other, therefore the slope of the radical axis will be minus 1. Am I correct? So now you know the slope of the radical axis, as well as you know that the radical axis is passing through the point A comma B. Therefore its equation will be simply by using point slope form, y minus y1 equals to m into x minus x1. So that gives us, so from here we can get x plus y is a plus b. Is it clear to all of you? So this is nothing but the equation of the radical axis. Is it clear? Absolutely. Hence option A is correct. So see in this question how we have used the properties of radical axis to solve this sum. Okay, let's move for the next problem. The question says that there are two circles intersecting each other. The first circle is your mu1 and the other circle is your mu2. Okay, so this is my mu1 whose equation is x square plus y square is 16. It implies that its center is at 0, 0 and radius 4 units. And the second circle we are having, which is your mu2, the center I don't know. We only know its radius, which is equals to 5. Now, they have said that this circle mu2, it has intersected the circle mu1 in such a way that the common chord has maximum length. The common chord is having maximum length. Does anything comes in your mind? What does it mean? That the common chord will be of maximum length. This is the common chord. This length is the maximum length of the chord in the circle mu1. Now, which one is the largest chord for any circle? When the chord is the diameter of the circle. Am I correct or not? So it actually states that the common chord, or you can say the radical axis, whichever, the common chord is basically the diameter of circle mu1. The common chord AB, let us say, the common chord AB is basically the diameter of the circle mu1. See, JEE people, they always used to give question in this way. They have not said that AB is the diameter. They have said that the common chord will be the largest chord. Now you have to understand that a chord is largest when it is the diameter of that circle. Is it clear? Therefore, the center of the circle mu1, it lies on this diameter, naturally, because that is the common chord. So, and since this common chord is the diameter, therefore, its center will lie on AB. And the center of the circle mu1 is 0, 0. Am I correct? Now, we have to find out the center of the circle mu2, whose radius they have given equals to 5. Okay? And what else the information they have given? They have given that the slope of AB, that is slope of the common chord, is 3/4. Okay? Now what I am doing is I am simply joining the two centers. I am simply joining these two centers. And let us say the center for the second circle, that is mu2, be alpha comma beta. Our main task is to find out alpha beta. Now let me give a name. This is my center C1, this is my center C2. Now from the property of radical axis we know that C1 C2 is perpendicular on AB. Am I correct or not? Because we know that the line joining the two centers of the circle is always perpendicular to the radical axis. In our case, in this problem, our radical axis and the common chord, they are same. Therefore, C1, C2 is perpendicular on AB. Now, as the slope of AB is 3/4, therefore, slope of C1, C2 is -4/3 because they are perpendicular to each other. Am I correct? Therefore, slope of C1, C2 is -4/3. Now, how can you find out the slope of C1, C2 by other method? By 2-point form, we can get beta minus 0, alpha minus 0 gives us beta over alpha, right? Therefore, beta over alpha is -4/3. From here, you can also write that your beta is -4 alpha by 3. Okay. Okay. What else? Now let me join C2 with B. Okay. Now please observe carefully. Your C1B is basically the radius for mu1, which is nothing but 4. C2B, it is the radius for mu2, for the circle mu2, whose radius they have given 5. So, as this is 90 degrees, so if we take the right angle triangle C1, C2B, in the triangle C1, C2B, what we can write? We can write C2B square is C1, C2 square plus C1B square, right? What is C2B square? It is 5 square. C1, C2 I don't know. And C1B is basically 4 square. So that gives us C1, C2 is 25 minus 16. That is your 9. That implies C1, C2 is 3. That is the distance between the center of mu2 and the center of mu1 is 3 units. And the distance between C1, C2, we can find it in other way. It can be written as root over alpha square plus beta square. So now we can say that alpha square plus beta square is basically 3 square, which is nothing but 9. Am I correct or not? Am I correct or not? We also got that beta is minus 4 alpha by 3. Let me take it on the other page. Your beta is minus 4 alpha by 3 and we got alpha square plus beta square is 9. Right? So now we have to solve for alpha and beta. So naturally we have to solve these two equations. So let me just replace beta by minus 4 alpha by 3. We are getting So from here we are getting alpha is plus minus 9 over 5. Alpha is plus minus 9 over 5 and your beta will be minus 4 alpha by 2. So we can write minus so we are basically getting minus plus, sorry, this is 3. So this and this goes off. So minus plus 12 over 5. Am I correct? Therefore, your alpha beta will be either 9 over 5 minus 12 over 5 or it can be minus 9 over 5 comma 12 over 5. Is it clear to all of you? Have you understood how I've approached to solve this sum? Therefore, our answer is A, right? 9 over 5 minus 12 over 5 and minus 9 over 5, 12 over 5, right? Hence, option A is correct for this sum. Okay, so always remember what we have learned from this problem is that whenever this kind of problem is given and whenever they are asking, see, two things you must remember. Whenever they say that one circle is bisecting the circumference of the other circle, then the common chord will be the diameter of the first circle. This way you remember, because I have done one sum of this kind. And in this sum, instead of saying you that this is the diameter of a circle, they are saying that the common chord has maximum length. So you have to understand, whenever the common chord is of having maximum length, it is nothing but the diameter of that circle. Right? So these are the two things that we have learned in these two consecutive problems. Okay, let us move for the next sum now. See, what is the question? Find the equation of the circle on the common chord of the circles this and this as the diameter. So all you have to do is you have to find out the equation of a circle and the common chord is, just one second. This is my common chord and let us say it intersects the two circles at A and B. Now AB is the common chord. You have to find out the equation of that circle which is not only passing through A and B, but it is also the diameter of that required circle. Getting my point? So we have to find out the equation of this circle. Right? This is our required circle. So for the required circle, what they have said? AB is the diameter of that circle. Now we can easily see that this is our first circle. This is the equation of this circle is given to us like this one. And this is our second circle which is given. So AB is the common chord which is also the radical axis for these two circles. Now, what is the equation of AB? Equation of AB. This will be what? Simply subtract one equation from the other. Right? So we are getting 2x plus 2 minus 1, that is plus 1 equals to 0, right? So this is the equation of the radical axis. In this case, it is our common chord. Now we have to find out the equation of this required circle, which is not only passing through A and B, but also AB is the diameter of that circle. Now any circle, listen it very carefully, any circle which is passing through, let us say, this circle and this common chord. Any circle which is passing through this first circle, this one, and the common chord is given by, this is all about family of circles. In this case, I am using. So this is the equation of all the family of chords passing through the point A and B. Now, if I simplify this into the general form we are getting, so what is its center? Center is at okay. Now, look it very carefully. This center for our required circle, the center must lie on this line AB because AB is the diameter of our required circle. The equation of the common chord AB is 2x plus 1 and the center is this one. Hence, it must satisfy this equation. So, in place of x, I am writing minus lambda plus 1. So, if I open the brackets, we are getting lambda is minus half. What is your lambda? Lambda is minus half. Is it clear? Now, the moment you get lambda is minus half, what is the equation of our required circle? It will be simply I am putting the value of lambda in this. So this is basically coming to 2 minus 1x plus 3y plus 1 minus half equals to 0. So that gives us So that gives us 2x square plus 2y square plus 2x plus 6y plus 1 equals to 0. And that is the required circle. That is the required circle. Is it clear? So what I have done in this problem? I simply found what is the common chord. I have to find out the equation of that circle whose diameter is the common chord of this given two circles. So first I found out what is the equation of the common chord, and then I have related this thing with the family of circles because our required circle is passing through the point of intersection of the first circle and the common chord. Now one can ask me, sir, why you have taken the first circle? If I take the second circle, the family of circles which are passing through the point of intersection of the second circle and the radical axis of the common chord, will it be the same? Yes, it will be the same thing. So there I got the family of the circles, and our required circle, in our required circle your AB is the diameter. Therefore, the center of the family of the circles I found. In our required circle, this center is lying on the diameter. Hence, it must satisfy it. From there, I got the value of lambda, and eventually I got the equation of the circle. Is it clear to all of you? Absolutely. Okay, let's move for the next problem. Now, see this question. They have said, show that the equation of the straight line meeting the circle x square plus y square equals to a square. This is the equation of the circle. A line is meeting this circle at 2 points. Let us say this is that line which is meeting the circle at 2 points. Let us say the points are A and B. Right? Now, which is of equal distance D from a point x1, y1 on its circumference. That is, they have said that there is a point x1, y1 such that the line joined from this point to A and B, they are of equal length. They are of equal length D. That much is said to us, and we have to find out, or we have to prove, that the equation of this straight line is whatever given to us. This is the equation of this straight line. So how to find it out? In this question, we will use a fantastic conception. So before that, let us just try to solve this sum by a normal method. Now, one thing from the given information can come in our mind that, sir, point P, let us say this point is P, which is x1, y1, is such a point that it is having equal distance D from A and B. So I can say easily that this point P is basically lying on the perpendicular bisector of AB, isn't it so? The perpendicular bisector of AB is this one, and your point P is lying on it, right? Because the distances are equal. From point P, the distances of A and B are equal, which is equals to D. So I can say that point P is lying very much on the perpendicular bisector of AB. It means, since this is the perpendicular bisector, hence it is definitely passing through the origin of this circle, which is 0, 0. Tell me yes or no. Okay, so how to find out the equation of AB? For that, we can do one thing. We can find out the slope of this perpendicular bisector, which is y1 minus 0 by x1 minus 0. That gives us y1 over x1. This is basically the slope of the perpendicular bisector. Yes or no? Is it clear? Then, what will be the slope of AB? What is the slope of AB in this case? The slope of AB will be, since this perpendicular bisector means it is perpendicular to AB, therefore the slope of AB will be minus x1 over y1. Tell me yes or no. Correct? Now, the question comes to this point that we now know the slope of AB. But other than the slope of AB, we don't know anything about the line AB. So how can you find out its equation? To find out the equation of the line AB, I need two things. I know the slope, that's good. But at least I must know one point through which the line is passing. But is it possible to find out that point in this scenario? Answer is no. Because you can ask me one thing, sir, if we can find out this point, then we will know one point on the line. I will say yes, absolutely perfect. But how you will get this point? To know this point, you must know this point and this point. And to know the points A and B, you must solve the equation of the line and the circle. But you don't know the equation of the line. That is actually what is required to find out. So I cannot find out their midpoint. Yes or no? So is it possible for us in this scenario to find out the equation of AB? No. Answer is no. And that is the uniqueness of this sum. That is the uniqueness of this sum. So for this, so now we are sure that by normal method we cannot find out its equation. So now let us try to do something extraordinary thing here. What we will do, We will try to find out equation of a circle whose center will be at P and whose radius will be D. It means that circle is going to pass through AB, that's for sure. Let me draw the circle whose center is at P, that is x1, y1, and radius D. So the circle must pass through these two given points A and B. Am I correct or not? So this is that circle which I have drawn, taking P as the center of the circle and D is its radius. It means this circle is passing through the points A and B. Am I correct or not? Then what will be the equation of this circle? The equation of the circle will be x minus x1 whole square plus y minus y1 whole square equals to d square. Center radius form. So if I open the brackets, we are going to have Am I correct? Now as x1, y1 is lying on the circle, x1, y1 is lying on the circle, x square plus y square equals to a square. Hence it must satisfy this equation. That is x1 square plus y1 square equals to a square. So let me just replace this part with a square we are getting. Am I correct or not? So this is the equation of this circle. And the equation of this circle is this. Now can you observe one thing? That here AB is the radical axis, or you can say common chord. For the given two circles? Yes or no? So how to find out the equation of AB? Simple, I will subtract one equation from the other. So you are going to have so this is the equation of AB, and the equation comes to so that gives us tell me yes or no, this will be plus. So this will be plus. So this is equals to 0. Therefore, the equation of AB is hence proved. This question actually it has been taken from Essaloni. So this is a very unique question. In this case, in this problem, we have tried to solve it by the normal method, but we faced a problem there. The problem was we found the slope of AB, but other than knowing the slope of AB, we know nothing about the line AB. Therefore, it's not possible for us to find out the equation of AB in that scenario. So here I have applied a new conception. The conception is that I have constructed a new circle in which the center of that circle becomes the point P and the radius I took as D. So the circle that is constructed is definitely going to pass through A and B, right? The moment it passes through A and B, we can see now we are having two circles, and AB is nothing but the common chord, or we can say radical axis of these two circles. So from there, simply by subtracting two equations of the circle, we got the equation of the radical axis, which is nothing but our AB in this case. And that exactly how we have solved this one, right? So it's a very good conception. We must remember the method of solving this sum, not the sum. The method of solving this sum. Maybe this conception will be applied in some other problem when little tricky questions like this used to come in our exam. Okay, so you have to adopt this method. Okay, so now let's move for the next conception, which is called your radical center. What is radical center? Now, if we take three circles, this is circle, the first circle whose equation is S1 equals to 0, the second circle whose equation is S2 equals to 0, and the third circle which is your S3 equals to 0. Okay? Now, if we take the circles pairwise, then we are going to have three radical axes. One is LO. If I take S1 equals to 0 and S2 equals to 0, the radical axis will be LO. If we take S1 and S3, the radical axis will be MO. And if we take S2 and S3, we are going to have the radical axis NO. Now, these three radical axes are going to meet at a point in this diagram. I have shown it with O. This is the point where the three radical axes are meeting. And this point is what called your radical center. Is it clear? So what is radical center? When the radical axis found by taking two circles in pair, all these three radical axes are going to meet at a point O, and this point O is what called your radical center. Is it clear to everyone? Absolutely. I will definitely prove this. I will definitely prove that these three radical axes are going to meet at a point. That is, three radical axes are concurrent. That we will prove. Okay, so let me take our three circles like this. The equation of the first circle is S1 equals to 0, where S1 is the second one is S2 equals to 0, where S2 is and this is our S3 equals to 0. The third circle is clear. Now what is our task? Our task is to prove that if we take pairwise these circles, if we take S1 and S2, we are going to have the radical axis like this. If we take S1 and S3, we are going to get a radical axis like this. And if we take S2 and S3, we are going to get the radical axis like this. Now, all we have to do is to prove that this point, that is the meeting point of this three radical axes, let us denote this thing by O, is concurrent. That is, these three radical axes are passing through the point O. Our main task is to prove that, right? Now, what is the radical axis Let me just give a name, then it will be better for us, otherwise. So what is the equation of the radical axis OA? It is S1 minus S2 equals to 0. That gives us 2 times F1 minus F2y plus C1 minus C2 equals to 0. This is the equation of the radical axis OA. What is the equation of the radical axis OB? So here we got S1 minus S3 equals to 0. So that gives us okay. And what is the equation of the radical axis OC? So if we do S2 minus S3, we are going to get the equation of the radical axis OC. So let me do it. Are you getting the point? So these are the 3 equations of the radical axis. Now we have to prove that they are concurrent. To prove this one, I have already taught you that when 3 lines are concurrent, what is the condition? What is the condition? And the condition is, you can do in this way, you can solve these 2 equations to get the value of x and y and put that x and y in the third equation, and you will see that it is satisfying it. It means that these 3 lines are concurrent. Now, I have also taught you one determinant method. In all those cases, determinant method acts as a blessing. So, what is the condition for concurrency? The condition for concurrency is, I am writing it in a determinant form. This is, if we can prove that this is equals to 0, it means that these 3 lines are concurrent. This is the condition for concurrency. Okay, so now those who don't know determinant, all you will do is you will simply expand this determinant, and then you simplify, you are going to get the value 0. That's for sure. Those who don't know the determinant. But those who know the determinant, they can simply use the properties of determinant to show that this is equals to 0. That's exactly what I am trying to do, simply by applying some properties of determinant. Again, I am telling you, those who don't know the determinant, you simply expand the determinant. You will find after simplifying it is coming to 0. Or even if you don't go for determinant, I told you solve any 2 equations and put the value of x and y in the third equation, you will see that it is satisfying. It means that the 3 lines, here the 3 radical axes will be concurrent. Clear? So now I am trying to prove that this determinant is 0. So right now I am not writing this is equals to 0. I will prove that this is equals to 0. So now I am applying some properties of determinant. What I am doing, I am taking 2 common from this first column and the second column. Then we are writing this thing as G3 minus G1, F3 minus F1 and C3 minus C1. Actually, we are having a minus sign outside. And the third row I'm writing it as now let me take minus common. Is it clear? Absolutely. Now what I'm doing is I'm simply going for this operation. I'm applying row 1 dash is row 1 plus row 2 plus row 3. So we are getting 0, 0, 0. And the other terms other elements I'm not writing, because the moment we got that one row is having all the elements equals to 0, so no need for writing the other elements. The value of this determinant will become 0, right? So we have proved that the condition for concurrency is holding true. That is, the value of this determinant is coming to 0. It means what? That these three radical axes are concurrent. That is, they are meeting at a point. And this point is what I told you is called your radical center. Is this clear? Is this conception clear? Have you understood what is radical center?
So what is your radical center? If we take three circles and pairwise if we find out the radical axis, they are going to meet at a point. This point is what called your radical center. As we all know in a triangle that orthocenter, circumcenter, incenter, centroid, they are one point of that triangle. Same like that, your radical center is also one point. That is, all the radical axes will be concurrent. And the point where this all three radical axes are meeting is what called your radical center. Is it clear? Okay.
Now let us take one example based on the radical center. The question is, find the radical center of these three given circles. Three given circles, one is S2 is and S3 is so now if you want to find out the radical center of those circles, we have to find out the equation of two radical axes. And if we solve two radical axes, we are going to get the radical center. So what is the radical axis formed from these two circles S1 equals to 0 and S2 equals to 0? It is given by, the equation of the radical axis is given by subtract one equation from the other one. This is the equation of the radical axis formed by the circle S1 equals to 0 and S2 equals to 0. So that gives us that is x minus y equals to 1. So this is the equation of one radical axis. The other radical axis, let us take two circles S2 equals to 0 and S3 equals to 0. So from these two circles, the equation of the radical axis will be Is it clear? So this is the equation of the second radical axis. So now if I solve these two radical axes, we are going to get the radical center. So let me just replace x by 1 plus y in this equation. We are getting so we are having y as 2. Now if I put y as 2 in this, we are getting x as, right? Therefore the radical center is 3, 2. Is it clear to everyone? You have understood how to find out the radical center when three circles are given? Right. So the answer is 3, 2. Okay? So now let us come for some properties of radical center. The first property says that the length of the tangents drawn from the radical center upon the three circles is always same. It's a common thing. It's very much true because when we are having the radical center, let us say the radical center is this point. Okay? So this means what? The three, actually let me just draw the radical axis. It will be better for you to understand. So this is the first radical axis, this is the second one, and this is the third one, correct? Now, so this point is basically the radical center. This is my radical center. Let us say this is my O. Now, from this point, we know that from any point on the radical axis, the tangents drawn to the two circles are of equal length. Therefore, if we draw tangents from this point, because this point is common point in this radical axis, in this axis as well as in this axis. So from this point, if we draw two tangents, one at this and another one is this, they will be of equal length. Again, from this point, if we draw this tangent and this tangent, they are again going to be of equal length. Because any point on the radical axis, if you draw tangents to the given circles, their length of the tangent will be equal. Therefore, this length, and this length, they are equal. Hence, the first property. The length of tangents drawn from the radical center, because radical center is a point which is common to all those three radical axes. Therefore, any tangents drawn from this point on the three circles will be same. Okay, that proves our first property. Now the second property says that the radical center of three circles defined on three sides of a triangle as diameter is same as the orthocenter of that triangle. Very, very important property I am telling you. Very, very important property. Let me just draw it properly first. What they have said, I will explain. Suppose we are having a triangle like this. Okay. Now what they have said, this is a triangle, let us say ABC. The property states the radical center of three circles defined on the three sides of the triangle as diameter. Means what they are saying? They are saying that if you describe three circles on these three sides of this triangle, taking the sides as the diameter. So if I just draw the first circle, taking AB as the diameter, so this is the first circle that I have drawn, which actually, in which AB is the diameter. AB is one side of the triangle. taking that side as the diameter, we have drawn this circle. Similarly, let me draw the other two circles. Let us say this is another circle which has been described on the side AC, taking AC as the diameter. And let me draw the third circle which has been described on the side BC, taking BC as the diameter. Okay? Now what they are saying, what is the property? It is saying that the radical center for these three circles is same as the orthocenter of the triangle. Are you getting the point? What they are saying, that is, we are having three circles, so definitely we are having three radical axes. Now the radical center, that is the point where all these radical axes are meeting, this radical center and the orthocenter of this triangle, they will be same. So what we have actually to prove here, if we can prove that the radical axis is the altitude of this triangle, if the radical axis is the altitude of the triangle, then it is equivalent to prove that the radical center will be nothing but its orthocenter. Am I correct or not? Because three radical axes are meeting at a point, three altitudes are also meeting at a point. So if the radical axes are all equals to its altitude, if we can prove that, yet it has not been proved, but if we can prove that the radical axes are all your altitudes of this triangle, then it is already proved that the radical center and the orthocenter, they will be the same point. Okay? So now my task is to prove that the radical axis and the altitude, they are the same line. Now let me draw the first radical axis, or in this case the common chord also. So this is our common chord. This blue line is the common chord, or you can say it's a radical axis. Now if we can prove that this, let me just give a name of this, let us say this is D. Okay, now if we can prove that this radical axis AD is basically perpendicular on BC, then what we have proved? We have proved that the radical axis is nothing but the altitude, one of the altitude of this triangle ABC. Similarly, we will prove the other radical axis are the altitudes of the triangle ABC. Clear? So now how to prove that the radical axis AD is altitude on the side BC? So now you see, for that prove what I am doing. AB is the diameter of the circle, the first circle. So let me say this is the center of that circle, C1. And AC is the diameter of the second circle. Let us say C2 be the center of that circle. Now if I join AB, if I join C1 and C2, if I join C1 and C2, look it carefully. So this is actually what? This is actually the line joining the two centers of the circle. We all know that when you join two centers of a circle, of two circles, that line is always perpendicular on the radical axis. So I must say that C1, C2 is perpendicular on the radical axis AD. Am I correct? So this is 90 degree. Okay. Now as C1 and C2 are the midpoints of AB and AC respectively, so in the triangle ABC, by using the midpoint theorem, we can say that C1, C2 is parallel to BC? Tell me yes or no. From the midpoint theorem, we can say C1, C2 is parallel to BC. Okay. Now, as AD is perpendicular to C1, C2, it implies AD is also perpendicular to BC. As C1, C2 and BC, they are parallel, and AD is perpendicular to C1, C2 implies it is perpendicular on BC. Is it clear? So, the radical axis AD becomes your altitude. Okay? Similarly, you can prove that the other radical axes are also the other altitudes of this triangle. So, we have proved that here the radical axis and the altitudes, they are same line. If they are same line, then radical axes meet at the radical center and altitudes meet at the orthocenter. Correct? Therefore, your radical center of the three given circles is same as the orthocenter of the given triangle ABC. Is this clear? Hence, our second property, which is a very, very important property as far as your MCQ questions are concerned, has been proved. Right?
So what are the properties that we have learned? First property is that from the radical center, if we draw tangents to all of these three circles, the length of the tangents will be equal. This is my first property. And the second property states that if we take a triangle, let us say ABC, and on each side, taking that side as the diameter, if we draw circles, so we are going to have three circles. For these three circles, we are going to have a radical center. If we take pairwise, so naturally we are getting the radical axis, they are going to meet at a point which is your radical center of that circles. Now, the radical center and the orthocenter for the triangle ABC, they will be equal. Please, I will suggest all the students, as I have told you repeatedly, try to remember this property by heart. Why? Because this property will help you to solve the problems in a much shorter way. Is it clear? Okay.
Now let us do some problems based on these two properties. Say this question. Find the radical center of the circle drawn on the sides as diameter of the triangle formed by these three lines. It means what? We have been given a triangle and we have been given its three sides. What are those sides? Let us say this side is 3x minus 4y plus 6 is 0. X minus y plus 2 is 0, and the third side is, right? Let us say the three vertices of the triangle be A, B and C. Now we have to find out the radical center of these circles drawn on these sides as diameter of this, the three sides of the triangle given, and taking each side as your diameter, you have drawn three circles. We have to find out its radical center. So just now we have learned that whenever three circles are described on the three sides of a triangle, taking the side as a diameter, their radical center and the orthocenter, they will be the same point. So one who knows this property can understand that this question is not at all a question from circle. If you know that the radical center and the orthocenter, they will be the same point, if you know this property, so you can understand that while solving this problem, I will not at all use anything in circles. I will simply find out the orthocenter of this triangle by finding out two altitudes and then solving it. That's it. Because that orthocenter will be same as the radical center. Am I correct? Okay. So what I'm trying to do, let me just solve first and the second equation to get point B. Let me solve it little fast. 3x minus 4y plus 6 equals to 0 and x minus y plus 2 equals to 0. So if we subtract, we are going to have minus y equals to 0 implies y is 0, right? Y is 0, and if we put it in the equation, we are going to have x plus 2 is 0 implies x is minus 2, correct? Therefore, the coordinate of B is minus 2 comma 0, right? Now, let me try to solve this and this equation to get point A. So let me just multiply this with 3 and this with 4. We are getting so let me just add this to implies x is 2, right? If x is 2, so we are getting y as 6. I'm putting it in this equation. So 6 minus 4y plus 6 is 0 implies y is 3. Therefore, the coordinate of A is 2 comma 3. Right? Now I have to find out the equation of the altitudes. So the altitude which is drawn from point A on this side, what will be its equation? The slope of BC is 1. Therefore, the slope of the altitude, let us say AD, is minus 1. Correct? Therefore, what is the equation of AD? Y minus y1 equals to m into x minus x1. Point slope form. So we are getting x plus y equals to 5. This is the equation of AD. Now we will find out what is the equation of, let me draw a perpendicular or altitude from B on AC. What is the slope of AC? The slope of AC is minus 4 over 3 implies the slope of BE. The slope of BE is 3 over 4, correct? Therefore, the equation of BE, the other altitude, BE is y minus y1 equals to m into x minus x1. Point slope form again. Right? So this is another equation that we got. 4y equals to 3x plus 6. So these two equations are the two equations of the altitudes of the triangle ABC. Now if we solve these two equations, we are going to get the orthocenter, right? Which is actually in this case our radical center too. Okay? So let me replace y from here. It's 5 minus x. So if we put it here, we are going to have x is coming to 2, and if x is 2, your y is coming to 3. Am I correct? Therefore, the orthocenter, which is same as your radical center, is basically 2, 3. Is it clear? Is this conception clear? You see, here I have used nothing. Only if we know that property that when circles are drawn on the sides of any triangle, taking that side as the diameter, then the radical center so formed by these three circles is same as the orthocenter of that triangle. If you know this property, you can do this kind of problems at much ease, right? Okay. So let me take another problem. What they have said that there are three circles of radius 2, 4 and 6 units. There are three circles of radius 2, 4 and 6, right? Now they are saying these three circles are touching each other externally at the point A, B and C. So let me say this point is A, this is my B and this is my C. Yes or no? This is my C. Okay? The radius for this circle, the radius for the first circle is your 2. So this is length 2. This is also length 2. Okay? For the second circle, the radius is 4. That is, this length is 4. At the same time, this length is also 4 because they are the radius of the same circle. And for the third circle, the radius is 6. So this is also 6. This is also 6. Am I correct? Right? So, if you observe, you will find that this length, what is this length? This length is 2, this is 2, this length is 6, this length is also 6, this is 4 and this is 4. Correct? Now, they have said that if P is the radical center, P is the radical center, P is somewhere here, right? If P is the radical center, find PA. That is, you have to find out the distance PA. This is my P. You see, since P is the radical center, so your PA is this. PA, PB as well as PC, they will be all same. Because we know that from the radical center, if we draw tangents to the three circles, their length are going to be equal. Am I correct or not? Okay, so how to find out the length PA? Either you find PA or PB or PC, all are same. Now one thing I can see that for the triangle that has been formed, the length of this side is 6. The length of the, let me give a name, PQR. Oh, P is there now already. Okay. So let me take this thing as XYZ. Right? Now, your length XY is basically 6. Your length XZ is 8. And the length YZ is 10. Now we can observe one thing, that 6 square plus 8 square is your 10 square. It means that xy square plus xz square is your yz square. It means what? The triangle XYZ is a right angle triangle. Am I correct or not? It's a right angle triangle, right angle at X. Okay, so this is your right angle at X. Now from there, the moment we have seen that this triangle came to 90 degree, so if we consider, look it carefully now, I have to find out what is my PA. So if we consider this quadrilateral, now what we can observe, this angle is 90 degree, this angle is also 90 degree. Why? Because this is the radius and this is the tangent, PA is the tangent. So naturally, since XA is the radius, hence it will be the normal also because it is touching the point of contact. Thus, your angle A is 90 degree because we know that the tangent and normal, they are always perpendicular to each other. So this is 90, this is 90. By the same argument, this angle is also 90. So obviously, this angle is also 90. Tell me yes or no. That is, this quadrilateral, now it becomes a square. It becomes a square. Why? Because from point P, you have drawn two tangents PA and PB, which are of equal length. Yes, these are the two. Actually, I can say that the triangle that is formed, that is your XBPA. This quadrilateral that is formed is basically a rectangle. But in this rectangle, the adjacent sides are equal. So this rectangle will become a square. And if it is a square, then all the sides are equal. Hence your PA will be equals to XB, which is nothing but 2 units. Tell me yes or no. Therefore, the length PA in this case is 2 units. Hence answer is 2. Is this clear to all of you? Have you understood this? Now, naturally a question can come, ki sir, fortunately you got this thing as 90 degree. But if so, that this angle is not 90 degree, then how to solve it? How to find out what is the distance P? Now, please see this one. Suppose if this angle X is not 90, it is something else. I don't know what is the angle, but it is not 90, that's for sure. Let us assume. Okay, so this is my triangle XYZ. Look it very carefully. Now, point P is such a point that your PA, this is your PA, and your PB, this is your PB, and PC, this is your PC. These three lengths, they are same because P is the radical center. So from the radical center, when you have drawn tangents to the three circles, they are equal. The length of the tangents are equal. So P is basically the in center. P is the in center of the triangle XYZ. Am I correct or not? It is the in center. So now how to find out the length of PA? Let us say, if you know properties of triangle, it can be done in one line. We know our formula R equals to del over S, where del is basically the area of the triangle XYZ and S is the semi-perimeter of this triangle. We all know the sides. We know what is XY, what is YZ and what is ZX. We all know these three sides. Therefore, it is easy to find out its area. It's easy to find out its semi-perimeter. So directly we can get this. But if you don't know this formula, then all you will do, you will simply apply class 10 mensuration. I will simply join these 3 points with the 3 vertices. Now, you know the area of the triangle XYZ. How? Because you know the 3 sides. So, by using Heron's formula, you can find out the area of XYZ. That you can do. Number 1. Number 2. This area is equals to the area of XYZ is same as the area of PYZ plus PXZ plus XPY. Am I correct or not? For these 3 cases, you will find out half into base into height. Your height is this length PA, PB, PC, which are same. Let us assume this is R. Okay? So half into base into height. For all these 3 triangles, you know the base because all the lengths you know. All the length you know. Yes or no? So, half into base into height, in that case, everywhere you are going to have what? R. So, I will take that R common and this area we know. So, from this equation, we will simply find out what is R. That is, whatever area we got divided by this part will give us R. Actually, this formula came from this only. I am not proving it right now because it will be completely a new thing over there. We will cover this thing in properties of triangle. So those who know, they can do it. If that angle is not 90 degree, how to find out the R, that is in this case your PA, length of PA, which can be used by the formula R equals to del over S. If you don't know that, you simply apply your class 10 mensuration. You can find out the length PA. Is it clear to everyone? Absolutely? Okay. Now let's move for the next 2 properties. The third property states that the locus of the center of a variable circle which cuts 2 given circles orthogonally is same as the radical axis between the given 2 circles. What do you mean by that? They are saying that if there are, let us say 2 circles, and you have to find out the locus of that circle which intersect these given 2 circles orthogonally. You have to find out the locus of the center of this circle which is intersecting these 2 given circles orthogonally, right? You have to find out the locus of this center. Let h comma k be any point on this locus. And the equation of the first circle, let us say, is S1 equals to 0. The second given circle is S2 equals to 0. And for the third circle, let us say this is S equals to 0. Where your S1 is S2 is and S3 is right. So these are the 2 given circles, S1 equals to 0 and S2 equals to 0. And you have to find out the locus of the third circle which is intersecting these 2 given circles orthogonally. Okay, so what I will do here is, since the set I have taken h comma k be any point on the locus, it means that your h is minus g and k is minus f, right? So I will find out the equation of the locus. Naturally, the locus will come in terms of g, but the moment I get g, I will replace it by minus h and I will replace f by minus k. Okay. Now, as the circle, okay, this is actually as I have written there, this is my, not S3, this is S. Now, as in the question they have said that S equals to 0 is intersecting S1 orthogonally. So what we will write? We will write 2 times G1G plus 2 times F1F equals to C1 plus C. Getting my point? We know this is the condition for orthogonality of the circle S1 equals to 0 and S equals to 0. And the condition for orthogonality of S equals to 0 and S2 equals to 0 is given by, am I correct? Now I have to find out the locus of the point of S equals to 0 for this circle, the locus of its center. So what I have to do is, basically we have to find out a relation between G and F. So here we will only remove the parameter C because C has been introduced by me. It's a parameter. The rest of the things are given to us. So if we subtract these two equations, we are going to have am I correct? Now, let us replace G by minus H and F by minus K. So we are getting am I correct? Thus, this is the equation of the locus of the point H comma K, which is actually the center of the variable circle. So the equation of the locus is right. Now we can easily see that this locus is basically the radical axis between the two circles S1 equals to 0 and S2 equals to 0. Is it clear? So the property states that the locus of the center of the variable circle which cuts the two given circles orthogonally is same as the radical axis between the given two circles. That's exactly what I have proved. I have proved that the variable circle, this is the variable circle S equals to 0. If this variable circle cuts the given two circle orthogonally, then the locus of its center is nothing but its radical axis. The radical axis of the given two circles. Yes or no? So this will be our locus of the center of the variable circle. Okay? Is it clear? Is this property clear to all of us? Okay. And what is the fourth property they have said? They have said now we are having three circles. Now we are having three circles. The property states that the center of a circle which cuts these three given circles orthogonally. Suppose we are having three circles over here, and there is one circle which is intersecting these three given circles orthogonally. Is it clear? Orthogonally. Then it states that the radical center for these three given circles, S1 equals to 0, S2 equals to 0, and S3 equals to, these are the three given circles. So the radical center for these three given circles is the center for this circle, for this black circle. The center for this circle is the radical center for this given three circles, provided this black circle intersects the given three circles orthogonally. That's the most important thing. If the circle cuts the given three circles orthogonally, then the center of this circle will be same as the radical center for these three given circles. And its radius will be, since this is the since this is the radical center, therefore the radius for this circle is same as the length of tangent drawn to any of the given three circles from this radical center. And its radius will be equals to the length of the tangent drawn from this radical center. Actually, my diagram is not perfect. That is why I cannot draw this tangent. Now, I hope it will be drawn. So, from this point also, if I draw the tangent, these three lengths are going to be equal. Right? Why it is so? Because we all know that from the radical center, if you draw tangents to the three given circles, their lengths are all equal. Therefore, the length of that is the radius of this circle is nothing but the length of the tangent drawn from this center, that is the radical center, to any of this circle. Okay? So, this is only true when the circle intersects the given three circle orthogonally. Then its radical center will be same as the center of the required circle. And its radius will be the length of the tangent drawn from the radical center to any of the three given circles. That's it. Is it clear?
So what are the two new properties that we have learned right now for radical center? The third property states that the locus of the center of a circle which intersect two given circles orthogonally is the radical axis for the given two circles. This is property 3. And what is your property 4? Property 4 states that the center of a circle which is intersecting three given circles orthogonally is same as the radical center for the given three circles. And the radius for this circle will be the length of the tangent drawn from this radical center to any of the given circle. Is it clear? Okay.
So let us take a problem based on this. See this question. The question is, find the equation of the circle cutting the following three circles orthogonally. That means I have to find out the equation of circle, we need two things. One is the center, another one is the radius. Now, the center of this circle, the required circle, will be same as the radical center, because the circle intersects the given three circles orthogonally, and its radius will be the length of the tangent drawn from radical center to any of the circles given. Okay? Now, to find out the radical center, what I will do, let me denote this as S1, this is as S2, and this is as S3. So, to find out the radical center, I need two radical axes. So, the radical axis that is obtained from the first two is this. So, that gives us so if I open the brackets, we are going to have minus 7x, then we are having plus 8y, and then we are having minus 16 equals to 0. So that implies, so this is the equation of one radical axis, and the other radical axis can be obtained by using this formula S2 minus S3 equals to 0. So what we are getting? So from here we are getting So we are having actually x minus 2y plus 10 equals to 0. So this is the equation of the other radical axis. Now, if I solve these two radical axes, we are going to get the radical center, which is nothing but the center of our required circle. So let me solve these two equations. We get, this is the first one, and the second one is I am multiplying with 4. So now if I subtract, we are going to have 3x minus 24. So x is coming to 8. When x is 8, we are getting 2y equals to 8 plus 10, that's 18. Y is coming to 9. Therefore, the radical center or the center of the required circle is at 8, 9, right? Now we have to find out the radius of the required circle. The radius of the required circle is the length of the tangent drawn from this point on any of this circle you choose, because their lengths will be equal. So if I choose S1, the length of the tangent, which eventually is the radius of our required circle, is root S1. So that gives us root over 64, 81, 16, 27 minus 7. So that gives us what? Root over of 145 minus 16 plus 20. So that gives us 149. Am I correct? So the radius of the circle is root over of 149. Thus, the equation of the circle becomes, by using the center radius form, we are getting so let me open the brackets. So if we simplify, we are going to have x square plus y square minus 16x minus 18y plus 145 minus 149 equals to 0. So that gives us minus 4, right? So that gives us minus 4. So my final equation of the required circle will be this. Is it clear to all? Absolutely. Simply by using the property we can find out, the equation of such kind of circles which is intersecting the three given circles orthogonally. Right? Okay. So now let's move for the last part of this lecture is coaxial circles. What is coaxial circles? A system of circles, every pair of which have the same radical axis are called coaxial circles. I'm telling you, I'm explaining it. Just wait. Suppose this is the radical axis and we are having circles which are touching each other externally. Let us say these two circles. Okay, so this line is basically the transverse common tangent, which is same as the radical axis for the circles when they are touching each other externally. So this is the radical axis. Now you see there are infinite number of circles are there, which if you take lot of circles are there, lot of circles are there on this side as well as in that side. If you take pairwise all these circles, any pair you choose, if I choose this pair and this pair, now these two pairs is also going to have the same radical axis. Am I correct or not? Now such kind of all circles are called coaxial circles. They are having the same radical axis. Is it clear? Now here I have drawn two circles which are intersecting each other externally. It may so happen that there are two circles which are intersecting at 2 points. In this case also you observe your radical axis is basically this one. Okay, now you can have infinite number of such circles which are passing through this 2 point of intersection. They are passing through this 2 point of intersection. There will be infinite number of such circles. In this side, I am not drawing it. In this side as well as in this side. Lot of circles are there. Yes or no? It can be like this. It can be like this. Millions of circles are there. But now, if you take any two of them in pairs, you are going to have the same radical axis. It means that these circles are what called your coaxial circles, in which every pair is going to have the same radical axis. Am I correct or not? So can you understand one very common fact is that when two circles, when a series of circles, they are having the same coaxial circles. When they are said coaxial circles, it means that these all circles are having the same radical axis. It means they are actually talking about the family of circles. Is it not like that? So coaxial circles are basically family of circles which are passing through the point of intersection of one given circle and the radical axis. It is the family of circles which are passing through the point of intersection of one given circle, any one you take, because the radical axis is going to be same for these two circles. So you choose any one of the circles and the radical axis that has been found. Any circle which is passing to the point of intersection of this circle and the radical axis are all belongs to the coaxial circles. They are all coaxial circles. Is it clear or not to everyone?
So what is coaxial circles? Coaxial circles are the family of circles in which every pair you take, they are going to have the same radical axis. So coaxial circles are basically family of circles in which any pair of circles if you take, they are going to have the same radical axis. Then we will say that this whole family is the coaxial circles. Clear? Okay.
Now let us move for problems based on coaxial circles. Now in this problem, you have to find out that coaxial circle which is passing through the origin. Coaxial circles to these two given circles. Right? So what I will find out that coaxial circles or that family, that circle which belongs to the family of the coaxial circles which is passing through the origin. So for that, first I have to find out what is the equation of the radical axis. So equation of radical axis for the given two circles is if I open the bracket, we are going to have a is not equals to 0, so we can write 2x minus a is 0. That gives us x is a by 2. Yes or no? Okay, so this is the equation of the radical axis. Now, the coaxial circle which is passing through the Coaxial circles means what? It's a family of circles which are passing through the point of intersection of this radical axis and any one of these two circles. Let me choose the first one. So all the coaxial circles are given by this equation. Am I right? Any coaxial circle is given by this equation. You can take the second equation of the circle also. You are going to have the same answer. So in this case, they have said that that particular coaxial circle which is passing through the origin. Hence, origin must satisfy this equation. So we are having right? So lambda is coming to minus a. Now let me put the value in this equation to get the actual equation of the circle. Therefore, the required equation, the required coaxial circle is this. Am I correct or not? Have you understood this? So this is our answer. So let me just tell you what I have done here. The question is find out the equation of the circle passing through the origin and coaxial to these two circles. Any circle which is coaxial with these two circles is basically the family of circles which are passing through the point of intersection of any one of these two circles and their radical axis. So that's exactly what I got. And as it is saying that the circle is passing through the origin, hence it must satisfy this equation. And putting the value of the origin, I mean x equals to 0 and y equals to 0, we are getting the value of lambda. And the moment we get the value of lambda, we put it in the equation to get our required equation of the circle. This is actually the method of finding out any coaxial circles. Is it clear? Always remember, coaxial circles are the family of circles passing through the point of intersection of any one of the circle and the radical axis. That's it. And then whatever condition is given, use it to find the value of lambda. Okay, let me take another problem. So in this question, they have said from a point P, tangent drawn to the three given circles. The three circles which are given, S1 equals to 0, where S1 is, S2 is the equation of the second circle. So 5 over 3 x plus y equals to y. S3 is your x square plus y square plus 2x plus 7 over 4y plus 9 over 4, right? So now remember one thing, that we have to find out. If you read the question, only the first part you will understand that they have said from a point P, tangents are drawn to these three circles and they are of equal length. They are of equal length. A point from which you are drawing three tangents which are of equal length. Actually, they are talking about the radical center for these three circles. Am I correct or not? They are talking about the radical center, because we all know that from the radical center, if you draw the tangents, all are going to have the same length. Is it clear? So actually your P is the radical center. Now I have to find out what is the coordinate of P. That is, what is the radical center of these three given circles. So for that, I need two radical axes. So to get two radical axes, let me choose the first two equations, that is S1 is 0 and S2 is 0. The radical axis for these two given circles is now, have you observed one thing? That to get the radical axis, we must go for S1 minus S2. But this formula is applied only when the circles are in the form of x square plus y square plus 2gx plus 2fy plus c equals to 0. Remember that. You see, in the second case, it was actually 3 times x square plus 3 times y square. So what I have done, I have simply first divided the whole equation by 3. Because I have to make the coefficient of x square and y square equals to 1. That's the reason why I have done. The same thing I have done for the third equation also. Right? So be careful while finding out the radical axis by using the formula s1 minus s2 equals to 0. Remember. Now if I open the brackets, we are going to have so this is the first equation of the radical axis, and to get the second equation I am subtracting s2 from s3. You can take the other equations also. You can subtract s3 from s1 also, doesn't matter, because we are going to have the radical axis, because ultimately my motto is to find out the radical center. How to get the radical center? Simply by solving two radical axes. So any two radical axes you can take. So if I open the brackets, I'm writing it here. So what we are going to have? So what we are getting? So we are having actually okay. So these are the equation of the two radical axes. So now let me solve these two equations, this equation and this equation, to get the coordinate of the radical center. So what I'm doing, I'm simply multiplying this equation with 3. So what you are getting? So if we add, we are going to have x equals to 0, right? We are getting x equals to 0. So if x equals to 0, your y is coming to minus 9 over 3, that is minus 3. Therefore, the coordinate of P is 0, minus 3. Is it clear? So now you got the radical center, which is actually in our question is the point P. Now see what they have said in the second part of this question. If the equation of the circle passes through P and which touches the line x plus y equals to 5, let me just write it here. The circle which is passing through point P is 0, minus 3. So the circles which are passing through the point 6, minus 1 and tangent to this line x plus y equals to 5. So it is talking about that circle which is passing through this point, that's okay, but which are tangent to this line at this point. Okay, so are they not talking about the family of circles which are passing through the point 6, minus 1 and the line x plus y equals to 5 is tangent at that point? Getting my point? Tangent to that point. Therefore, the family of circles which are passing through the point 6, minus 1 and the line x plus y equals to 5 is the tangent is given by am I correct? Now I have to find out that particular circle which is passing through point P. Okay, so what is that? Point P must satisfy this equation. So let me put the values x equals to 0 and y equals to -3 in this given equation. So what we are having? So from here we are getting lambda is nothing but 5. Therefore, the required equation of the circle is, so let me open the brackets. Clear? So let me just simplify a little bit. Y is here, so 7y, and 36 plus 1, 37 minus 25. So it's basically 12 equals to 0. Am I right? Okay. Now, in the question, look at carefully. In the question, they have said that the equation of that particular circle is given by this equation. What is the equation? The equation is x square plus y square plus gx plus fy plus 2c equals to 0, right? That is the equation which is given. And now we have to find out the value of g plus f plus c. No problem. I will simply compare this because this equation and this equation, they are the equation of the same circle. So if I compare, we are going to have g as -7, f as 7, and 2c is 12 implies c is coming to 6. Therefore, the value of g plus f plus c is -7 plus 7 plus 6, which gives us 6 only, right? Therefore, our answer for this sum is nothing but 6. Have you understood this question clearly? What we have done? Slowly you break the problem what is given and then try to solve the equation and remember all the properties of the radical axis, radical center that we have learned. So we can do this kind of problems at ease, right? So that's all about this lecture. We will be meeting with the last tutorial on circle very soon. So till then, tune to us. Don't forget to subscribe, like, and share the video if you really like. Thank you so much.